Let's go through the code 2461. Maximum sum of distinct subarrays with length k. So for this question, it gives us an integer array and trying to let us find those kind of subarray which has length k, for example, 3, length 3, and it needs that this subarray, every element in it is distinct. For example, if this one will not count its sum, and find the maximum sum of it. So the thing is that for this question, we can also use 2 pointers and a right pointer, a left pointer. And we are going to use a set to add those kind of elements into the set. So what are we going to do is that previously, like 2 pointers, that is, we add those kind of things to counts or sets or the kind of things, right? But now, before we count this kind of right index, we need to check whether the set already contains this element or not. If it already contains, what we need to do is that we are going to move the left pointer until we see this element. And then we remove this element from this set. And also the left set, we know the other elements, they are distinct. Every time we move the left pointer, we will also move other elements from the set. Also when we have another condition is that when does not, those kind of things are distinct, right? And then that is our right pointer is going to move every time it move, trying to check whether there is distinct element in the set, and move to a point which have a size k. Then we can compare with maximum longest length. And in that case, if this k our left pointer, after we compare, our left pointer will also move 1 step to the right, right? And then we use the for loop of the while right pointer, trying to see whether it can move. Before it moves, it will also check the set. Every time we move the left pointer, we need to remove that element from the set. So let's begin to write code for this. We'll say n equals num.length, and we're going to use a set to store the distinct element. So we'll say int left equals to 0 for int right is 0, right is the margin, and right plus. Now the thing is that we need to firstly compare whether we are not add the right, count the right index right now. Instead, we are write something like if the set contains right. and we're keeping moving the left pointer. So I use a while loop, while left smaller than right, and set compense nums right. What we are going to do is we'll do left plus plus, right? And when this left plus plus, what we are going to do is that we'll set remove nums left, right? And after and also, yeah, the thing is that we're trying to find the maximum sum, right? So we have a long sum for 0. And when this will move, we'll have sum minus equal to nums left. Right. So after jumping out of this while loop, that means we are able to add the right number to count the sum, right? So in this case, what we are going to do is that we'll add nums right, and also sum greater plus equal to nums right. Every time we compare and we add. So when this jumping out of this loop, we'll compare whether the size is k or not. So we'll say if right minus left plus 1 equals k, right? It means if we go here, it means everything between left to right, they are distinct. And now we are only after the sum that is right, the size is k, right? So if the right minus left plus 1 equals k, let's say longest equals mass. Sorry, we have a maximum, right? Now we are trying to say max. There max equals max dot max. Max and sum, right? So if the size is already k, right? What is the next step? Is that we need to move the left pointer to 1 to the right. So if we move that, what we are going to do is that we have left plus plus, right? So for every left plus plus, that we do two things: is set or remove nums left, and we'll have sum minus equal to nums left, right? And in the end, we just need to return sum max. Okay, so the time complexity is ON because we use 2 pointers. And the space is that we have a set, right? This set, at least it can have k elements, so it will be OK space.